Welcome to the VIIRS Active Fires teletraining session. My name is Jarrell Torres, and I work at the Cooperative Institute for Research in the Atmosphere, CIRA. I will lead the teletraining session today, so let's get started. Here is a list of learning objectives for this teletraining session. Users will discover the importance of the VIIRS Active Fires product while understanding the product's algorithm, resolution, and latency of the data. Users will also be able to interpret and sample the product and become aware of the product's applications and limitations. Additionally, users will learn about product access in AWIPS and online and find the corresponding product training materials and resources. So what is the VIIRS Active Fires product? The product is derived from the Visible Infrared Imaging Radiometer Suite VIIRS instrument that is on board 3 satellites: the SUMI National Polar Orbiting Partnership (SNPP), the National Oceanic and Atmospheric Administration 20 NOAA 20 satellite, and the NOAA 21 satellite that provide information on fires and thermal anomalies across the globe. Users such as deployed meteorologists and incident meteorologists, or IMETs, are able to use the data to support agencies in operational fire response decisions. Specifically, the product monitors the distribution of fires and their intensities. For example, fire radiative power, or FRP. The product also helps in the identification of new fires or fires that are currently active. Can you tell me more about the product itself? Yes. Now, the VIIRS Active Fires product algorithm is complex. However, here are the main highlights. The product has a hybrid and contextual algorithm that builds on the MODIS Fire and Thermal Anomalies product that has 3 main display aspects: fire pixel location, fire confidence, and fire intensity, or FRP. The product also includes persistent anomaly flags, such as solar panels. The algorithm also contains an internal cloud mask to identify areas where fire detection was not attempted, and also includes a water classification scheme. There are also several wavelengths that are utilized in the algorithm, where the 3.74 micron and 11.5 micron are employed for fire detection. The product's spatial resolution is 375 meters, and the temporal resolution over CONUS is at least 2 overpasses per day per satellite. Now, if you're an Alaska user, you'll have more frequent coverage. Lastly, the data latency of the product is approximately an hour to hour and a half via regional LDM, or approximately 30 minutes if you have access to direct broadcast data. In AWIPS, how does one interpret and sample the product? The VIIRS Active Fires product comprises of pixels that are color-coded, from yellows or less intense fires to dark reds and purples, the most intense fires. The color spectrum also includes ranges of quantitative values expressed in megawatts, or MW. Note, MW is a proxy for fire intensity. Now, 2 product examples are shown of the Moose Fire in Idaho, shown here, and fires in New Mexico. To sample the product in AWIPS, right-click on the fire pixels and select Sample. The corresponding product attributes will appear: the timestamp, the satellite where the data came from, the fire confidence interval, low, nominal, or high confidence, and the FRP expressed in megawatts. We will now transition to the applications of the VIIRS Active Fires product. The product helps identify fires and point sources of smoke 24/7, day or night. As we noted in the previous slide, the product uses FRP as a proxy for fire intensity. FRP is essentially the rate of emitted radiative energy produced by a fire or anomaly over a domain. The higher FRP values equate with higher fire intensity and/or larger fires. Note, be aware of the burning characteristics that also depend on fuel type, moisture, temperature, and wind. The VIIRS Active Fires product uses its high spatial resolution, 375 meters, to detect small and less intense fires than geostationary data, such as the GOES 16 and GOES 18 satellites, and includes persistent anomaly flags, such as gas flares, that can be displayed when users sample the product in AWIPS. Lastly, also know that the VIIRS Active Fires datasets are utilized in smoke and air quality products, such as the such as the high resolution rapid refresh smoke HER smoke model. Now, with every product's applications, there are also limitations that users should be cognizant of. Obscuration from terrain, thin clouds, and thick smoke may obscure or lower fire intensity values. Note, areas with thick or cold clouds are currently masked by the internal cloud mask, but algorithm improvements are forthcoming to minimize the loss of fire information in cloudy pixels. When using the data, also be aware of daytime and nighttime false alarms. Daytime false alarms consist of reflected solar radiation from solar panels, hot and bright surfaces, sun glint from small lakes or ponds, as well as reflection from clouds. The nighttime false alarms consist of hot smoke plumes and reflected solar energy from cloud tops near the terminator. The temporal resolution should also be considered, with limited refresh rate over CONUS compared to the northern high latitudes, such as Alaska. How do users access the data in AWIPS and online? Note, the data is available in AWIPS for both CONUS and Alaska users. In AWIPS, generally speaking, users can go to the Satellite tab, scroll down to SMPP and NOAA 20, then to Derived Products, and click on SMPP NOAA 20 VIIRS Active Fires LDM. Note, the global data is also available for users online via Real Earth. Refer to the link shown on the slide. Now, before we come to a close, here is a quick case exercise of the Hermit's Peak Calf Canyon fire that burned over 300,000 plus acres last year in New Mexico. Note, the VIIRS Active Fires product is overlaid onto the VIIRS 0.64 micron on 2 May 2022. Using the VIIRS Active Fires product, which side of the fire is the most intense at 20Z? I will pause for a moment so you can analyze the data. Any guesses? The correct answer is B. The southernmost portion of the fire exhibits the highest FRP values, with values in the range of 351 to 900 megawatts or MW, seen in the dark red colors. As I conclude this teletrain session, here is a summary slide that comprises tips for assessing VIIRS Active Fires detections with VIIRS imagery, and additional resources and links to learn more about the VIIRS Active Fires product. If you have any questions, you can ask away, or you can connect with me via email, seen in the bottom right of the slide. Thanks for attending the teletraining session today.